Okay, so good afternoon to everybody. It's a pleasure this afternoon to have told by David Otero. You know, he's visiting us from the University of A Coruña in Spain, but he is a second year PhD student, and he works on information retrieval, experimental evaluation, and how to build test collection more efficiently. So this is indeed the topic of this talk this afternoon, building test collection for information retrieval evaluation.
Okay, so hello everyone. It's a pleasure for me to give this talk today, and I'm gonna take this time to talk a little bit about how the process of building new collection for information retrieval evaluation works, and I will also cover some problems that we may find in this process, and then I will also explain some solutions that we may propose to these problems. So first of all, I'm gonna begin from a very high level perspective, and I'm sure that you all know how a search engine works, right? Where you issue a query to the system, and the system provides you with relevant items to your query. So the question here is, how do we know that these results are good, right? So how do we can know if the results that the system is providing us are enough to satisfy our information need? And so when we approach the evaluation of information retrieval systems, broadly speaking, we can divide all these approaches into main groups. The first one is online evaluation that involves real users in the loop, and so for this reason, you are able to better measure how the user behaves in a real scenario. But the main problem here is that this type of evaluation is usually very expensive, and so we have also the offline experiments that we can conduct, which that are a lot cheaper than online evaluation, and that are also highly reproducible. And for these reasons, it's usually the first step taken when developing new retrieval engines. And today I'm gonna focus in particular on offline evaluation. And so when we perform experiments in an offline fashion, we need at least three main components, right? The first one is that we need a text collection. And this collection comprises a set of queries that represent the information needs of the users of your system. You also will have a set of documents that will contain the information that your users are going to search for. And then you also have a set of assessments that establish which documents should be retrieved for each of the queries, right? So having this collection, we can run our system against it and obtain a set of results for each of the queries that we have. And so the next step in this evaluation is that we are gonna use some metrics such as AP or precision at 10 or NDCG and so on to compute an effectiveness value of the results that our system gave us. And finally, if you want to have a higher confidence on the results that you are evaluating, you should perform some sort of hypothesis testing to check if the results that you are getting are really statistically significant and not only by luck or by chance, right? So with this framework, now we are able to evaluate our results. But today I want to focus on how we can build the first component that I mentioned, which is address collection. And in particular, I want to focus on the fact that obtaining those assessments is usually a very expensive task, because it requires assessors to review those documents, right? And so in the early days of IR, our collections were enough small that we could judge all the documents, but this is not the case anymore. And so for this reason, modern test collections are usually built with a technique which is called pooling. And so the main idea here is that the reviewers are only going to see a subset of the whole document corpus in the collection. For example, in this case, we have the room A and the room B that provides us with a set of rankings for each topic. So we are building those subsets by taking on the top 10 documents of each room, where usually that case is equals to 10, right? And so then, as I said, assessors only review those documents in the pool, and by the alphabetical order to avoid any bias. And so with this approach, researchers have been able to build larger and larger test collections while maintaining an acceptable cost. But I want to point out here that what happens if we cannot perform this whole set. And in particular, I want to talk about two main problems that we identified here. The first one is that, to build the pool, we rely in that we have the results from the participants. But what happens if this is not the case? You can imagine, for example, that you are the organizer of a new retrieval and novel task, and you want to provide your participants with label training data so they can train their models. And so, you want to build that label data without having the participants. And so I'm going to talk about a little bit on how we can tackle this problem. And the other question I want to talk about is that, as I said before, the documents in the pool are reviewed by the alphabetical order, but maybe we can do better than that and think of another strategy and to stop the process earlier so that we do not have to review every document in the pool while maintaining an acceptable quality and reusability of the assessments, right? And so I'm going to begin, I'm starting with the first question. And this was indeed the main idea that motivated this work that I'm showing to you right here, which is a paper that I wrote with my supervisors called The Wisdom of the Rankers. And in this work, we wanted to develop a strategy, as I said, to somehow be able to build and to gather new assessments when you do not have participant systems available. And what we did was to create synthetic rooms using some well-known ranking methods, such as the M25, the vector space model, also the language models from the statistical frameworks such as those based on derived priors and so on. And so with these rankers, now we only need a query to issue them and to create those synthetic rules. And so how do we create those variations of the queries? Well, what we tried to do was to employ a set of queries that already existed at the time when we did this work. I mean, this is not something that that we did in this paper, and we also wanted to explore if it is somehow possible to create queries in an automatic way. And what we did here was to expand the original title of the topic with the most discriminative words in the description narrative section of the topic in terms of IDF. So what we do here is like we take all the words that are in the description in the narrative section, we rank those words by IDF, and we take the top one as expanded terms of the original title of the query. And so with this strategy, we created 4 different sets of ranks that are going to serve as the input to from which we are going to pull the documents. The first set is created by just using the title of the topic against those 72 rankers, right? So, for example, here for topic 302, we have the title portfolio. So we will just use that query as the input of the rankers, right? We also created a second set of rules, performing the same strategy as before by using the description of the topic. So, for example, we have here the description of the same topic as before, and we use that description as the input to the rankers, and we call this set title description because in this set we also include the rules from the previous one, right? And additionally, we also created a third and a fourth sets using the manual and the automatic queries that I explained before. And you may note here that for the manual one, we only employed 8 variants per topic because it was the minimum number of variants that were available for everything. And so, okay, right now we have synthetic rooms created that we can use to pull the documents from them. And so what we did next is to use, as I said before, we think that we can do better than sorting the documents in the pool by the identifier, right, by the alphabetical order. So we tried with several pooling strategies to perform this task, and in particular we used OpenD, that's the name of, when you sort the documents by the alphabetical order as a baseline, we use it as a baseline. We also tried how move to from works here, which is a pooling strategy that has been demonstrated in the past as a very robust one to gather new assessments. And finally, we also propose an additional strategy that basically sorts the document in the pool by the times they appear in the ranks, right? So at this point, we have all the setup ready to gather new assessments when no participants are available, because as I explained before, we can generate synthetic rooms, and we can also pull the documents from them in a better way than in alphabetical order. And so moving on to the evaluation part, what we wanted to study here is how reusable are the judgments that we may obtain from with this approach, right? So what we did was to compute the Kendall correlation between the ranking of the official rules, right, with the official evaluation from TREC, and a ranking with the correlation with this proposal, and we compute the correlation between those rankings, right? And so it is like a very extreme definition of reusability, because you are not evaluating any of the ranks that you use to build the process. I mean, we are ranking the official rules, not the synthetic that we have created. And so in this table, we can see the reusability results, and we performed this experimentation on the robust and diversity collections. And you can see here the Kendall correlation and the AP correlation of the pre-coding methods that I mentioned, applied over the set of rules that I explained before. And also, it is important to note that all these judgments, all these values, were obtained when limiting the number of assessments per query to 5. Right. So here we can see that somehow, as expected, the best results are obtained with the manual queries, and in fact, we can see that in most of the cases with the top full thread and run strategies, we are able to reach correlations above 0.9, which is usually acknowledged as very robust, a very robust threshold, and we can also see the results that we obtain with the automatic queries that obviously are not as good as the ones obtained with the manual queries, but you know, we can observe here that it is possible to obtain strong correlations of ranking when building the assessments where no participant systems are available, and generating them, you know, simulating the statistic rooms using well-known and well-established ranking models. So this was all about the first question that I wanted to cover. And so now we are moving into the second one. And if we recap how pooling works, right? As I explained, the documents in the pools are sorted by alphabetical order. But the question here is, well, maybe we can do better than that, and develop a strategy that helps us to find relevant documents earlier in the process, avoiding us to the work of having to judge all the documents in the pool, right? And so it turns out that this is a common research question. I'm not discovering anything new here, but I want to explain one of these strategies that have been proposed in the past, which is based on multi-arm bandits, right? So the multi-arm bandits framework is in something imported from the reinforcement learning world, where a user faces a set of gambling machines where we do not have any information about the distribution of these machines. And so every time the user plays the machine can obtain a positive or a negative reward. And so the objective here is to maximize the total reward that the user gets over as a set of plays, right? And so, you know, the different models developed under this framework help aim to balance the exploration framework, the exploration trade-off, because you can somehow try to explore new bandits that have not been played a lot in the past, but you can also you may also want to exploit those that you know that work well. So applying this method for information retrieval evaluation, and in particular for building new test collections, what we have here is a set of 3 rooms, where each of them has, you know, a ranking. And so, for example, the user, well, this guy here is the reviewer of let's say, for example, a track evaluation campaign. And so we may begin the process by sampling from the first round. And so we see a non-relevant document, we get a non-relevant document. And so we now can update the distribution of this run accordingly. And so, you know, since this run has provided us a non-relevant document, now we may want to explore another run, for example, the one in the middle. And so now we see a relevant document and we update the distribution accordingly. And so now we decide to exploit this run because we think that it may provide us with more relevant documents. And so this process continues until you empty your budget, until you have enough documents added, or until you just exhaust all the tools, right? And so, well, this is, as I said, this is an idea that has been proposed in the past, and we know that it works quite well. So I'm not going to go into the details of this idea, but I'm explaining it here because you know, as I said, now we know that we can do better than sorting the documents by the alphabetical order. But so all these strategies that try to you know, explore the tool in another with another strategy, we have noticed that all of them rely only on the relevance or single relevance values of the documents. So there any of these strategies takes into account the actual content of the documents. And so we are arguing here that we may use that document to estimate, to better estimate the relevance, right? And so explore the pools in a better way. So the idea here is to employ a relevance feedback model from the statistical language frameworks such as DMM or M3 to rerun the documents that we have not seen yet. But before explaining how we can apply this to the pooling of documents in building new test collections, I'm going to broadly explain how these relevance feedback models work, right? So in the early days of AI, the first search engines only considered the initial query that the user issued, but it was soon demonstrated that we may somehow gather some relevance feedback from the user and use that feedback to improve our system and to provide the user with a more with an improved one, right? So in a real relevance feedback scenario, we may think that, for example, the user can mark the first document are relevant, and so the second and the third ones are not relevant for the user. And so these models work by taking the positive feedback given by the user to estimate a new model of relevance and rerun the documents. But the main problem here is that gathering that real feedback from the user is it's very costly and do not works in reality. So the main research focus here was on developing strategies that apply this idea, but without interaction with the user. And that's the reason why these techniques are called usually zero relevance feedback, because you are not receiving any real feedback from the user. And so the idea here is that, okay, well, maybe we can just assume that the top K documents are relevant. And so we have now a relevant set that has more documents, and we can compute another ranking using that information that maybe can better satisfy the information need of the original query of the user, right? And so what we wanted to do here for pooling is to use these methods to rerun the pooled documents that that have not been judged yet in the process, right? So we came up with 3 methods, right? The first one, well, I'm gonna from now on, I'm gonna mention only the element because from our experiment, it was the method that worked the best. So I will just ignore the rest of the methods, right? And so, well, the idea here is that we can use those methods to rerun all the pooled documents, right? So you take the top 100 documents from each room, you create a set from that from those documents, and you use this model to take into account the real relevance feedback that you get from the assessors to rerun the pooled documents. And we also tried these 2 methods here, and this stands for matching, which is a pooling method based on multi-arm bandits. But in this case, what we do is to rerun the documents of each participant independently. So I just prepared here a very small example to better show you how this works. So, for example, we may have this set of documents. Well, maybe this is somehow misleading. Just imagine that we don't have the real judgments of these documents, right? So these are our unjudged documents. And so what we do here is that well, we begin exploring this set here, for example. So the assessor sees this document and it says, okay, this document is relevant. And so now this will be our relevance, right? And so we now can use the relevance feedback model to rerun the documents that have not been judged yet, with the hope that the relevant documents are gonna come first, right? And so, this process just continues until all the full documents are done. And so this was, this is the first idea where we, yeah, so.
Are you going to rerun every time that document, or if you get one relevance, if you get another relevance from the event, you just stick to that? So
No, we rerun every time and a relevant document appears.
every time.
Yeah, because since the computation of the model relies on verification in the relevant documents, every time a new relevant appears, we can take this information to compute a better estimation of the model.
You don't have kind of a actual saying, well, if it is going well, because you keep having relevant documents, it means that you're ranking.
Yeah.
You want to stop there, you have any vehicle.
Yeah, but I don't, yeah, that is a good point, but I think that, you know, I don't believe that adding relevant documents to the model, to the relevance that we harm the computation of the model, the estimation of the model. We hope that adding relevant documents results in a better estimation, and so a better ranking.
There are estimates about if it is true that it's not harming, or if after a while it's harming. It might be.
Yeah, well, to be honest, I don't know, but it could be maybe a line to explore.
Yeah, it's a question. I really don't know what's going on.
Okay, so as I was saying, you will just keep pulling the documents until, or you just are fine with the adjustments you have, or you want to maybe keep going. So this was the idea that ran with the whole tool. Now I'm going to explain how we can combine that with a bandit technique. And so, as before, we have here a set of rooms from which we are going to sample documents. And so, as before, for example, we begin sampling the first room, we get an unrelevant document. And so now we may want to change to the last one. And so here, now that we have a relevant set, we can apply the same thing we had before, but just only for relevanting the documents in this part of the file, right? So if we have, we just have got a relevant document in this part of the file, we know we are going to sample from this group. And so we use the same model as before to rerun the documents in the room with the hope that the relevant ones are gonna come at the top, right? So we sample again, and we get another relevant document, and we will just apply the same idea until we are fine. Okay, so this was the main idea. Now, moving into the evaluation part, the first thing that we wanted to know here is that if we are able to improve the ratio at which relevant documents appear in the pool, right? So for each adjudicating method, it creates just a sequence of documents of assessments for each topic, so we can compute the recall at any point of the sequence. And we also use the AUC to summarize these results, right? So here we can see, okay, so we have here the results for track 7 and for track 9, right? And so we have the AUC's value, average overall topics, when we give the number of documents. So for example, this column means that we are only getting 100 assessments per each topic. And so, well, these are the strategies that I mentioned before. These ones are our guidelines. And these three are the ones that I mentioned before. So here we can see that overall, independently from the technique we are using, we can conclude that it is possible to obtain higher values of relevant documents, of the number of relevant documents very early in the process, right? Because having the 72, for example, here, for example, having the 72% of relevant documents only with 500 of judgments per query, it's a very you know, a very low number in comparison with the original set of judgments in the collection. And we can also see from this table that using the relevance feedback with a dynamic technique improves over the results of using it alone. So we can conclude that you know, using relevance feedback may be a suitable approach when we want to gather more relevant documents in the process. And finally, we can also see that max mean is the technique that obtains always the best figures, and in some cases even with statistically significant improvements over one of the baselines, which is and so, okay, here we can see that, as I said, we are able to gather, to improve the ratio of at which we find relevant documents in the pool. But this is not only the only property. Sorry, this is not the only property that we have that we want to have, because we may be sacrificing the reusability of the collection. You know, maybe well, we have more relevant documents, but our evaluation of the rooms, it's a crap. So what we did here was to check if we are able to maintain the same ranking of systems as in the original evaluation. So what we do here is, well, we rank the official rules using the plural from track. We rank the same set of rooms using our techniques, and we compute the 10,080 correlation between those rankings. And so here we can see that, well, what we see here is the number of judgments that are needed per query to obtain a correlation value equal or higher than 0.9. Right, so again, overall, independently from the technique, we can see that it's possible to obtain very strong correlation with a number of judgments that is, as I said before, a lot less than the original size of the pool. And we can see again that from this perspective, the technique that combines the Bandits method with the relevance feedback obtains the best figures. And so that was it. From this talk, in this talk we have saw how we can propose, how we can build new collections where no participant systems are available, providing a way for research teams that maybe do not have the same resources as big companies or other groups to build new collections. And so we are providing them with a tool to gather new assessments. We saw that to this regard, using an intelligent, let's say, pooling strategy works well. And as future work, we plan to include more types of systems. So, for example, apart from using the ones that I mentioned, like BM25, we can use some neural models that are known to work really well nowadays. And we also plan to study how other pooling strategies such as Edge works in this environment, right? And so regarding the other idea, we explore the use of relevance feedback to gather new assessments, and we show that, well, it is approachable, it is a suitable technique for this task. And to this regard, we plan maybe to research another feedback methods, because You know, since we also have the negative feedback from the assessors, because they also assess document as non-relevant, we can start the use of negative feedback methods that take into account this negative feedback. And so that was it. I hope that at least you learned something new today. It was a pleasure for me to be here. So thank you very much. And if you have any questions, I'll be pleased to try at least to answer them.
Thank you very much for being on the very nice talk. Any questions?
Yeah, no, okay. So from me, I received something like 5 months or so.
Okay.
Yeah, it's not so you are using the relevance set
Yeah.
documents obtained from one of the rounds to also around the others.
Yes, yeah. So I mean, yeah, maybe the example is a little bit misleading, but the relevant set is common to all the runs. So imagine if I get, you know, the relevant document, I will also add it here and use these 3 documents to run. Well, the documents from the runs.
Our question will be all the documents every time. All the relevant documents.
Yeah, yeah.
So basically, the question. Okay, I hope you use just one. Did the new one to prevent everything?
No, we enlarge the relevant set. Yeah.
Yeah, I missed it. Yes.
So in this case, yeah, Juliano said we use all the relevant documents from all the runs.
But then you prevent only the last one.
Well, in practice, you only rerun the one that you are going to sample, because there's no need to, you know, yeah.
Okay.
So, for example, maybe next I will sample from this one, so I will rerun only this set of documents.
And yeah, it makes sense that you are going to explore models, especially in the first part where you are creating mentioned without months. What I'm feeling of your first set of experiments is that you know if you use in a block time, like I said, very last. And you compare the systems used for cooling at the time, and you use different running models. Could be that you are actually, you know, very close to the real systems, since they didn't do anything really different one from the other. Using the N25, different parameters, or different parameters, but we know that they are all quite close. The other, so it's synthetic, but maybe very close to the real ones, and that's why we want to have good results. But if you change the task, something, I don't know, the entities, or you change, or you move more recent collections where you have an evidence system that allows you to retrieve very unique documents because of the and stuff like that. Never be more challenging or involved in active changes, but
yeah, that's a very good point. But I mean, the problem here, as you said, would be if we find a new model that is, you know, very different from the ones that we used. And so, I mean, the question here, my question here is, what are the possibilities of finding a new model that it is completely different from the ones that we use? Because at the end, all the models follow, you know, all the engines and all the models and all the ideas follow the same principle that you run. You want to rank the documents that have the most probability of being relevant higher, right? So I guess that the chances of finding of the or developing a system that is different enough from the ones that we use to harm the results are very likely to not happening.
Yeah, that's exactly. And if you want to simulate a person, you say, okay, you can create collection with systems, can do how you select this systems. And maybe you take a collection where you use the values in the process. Like,
Yeah.
and you say, okay, I do this selection without the values. And still, I get very close to very close to the final result, the original one, because the values are not having much. So your conclusion might be, yeah, if you are creating something synthetic, you can use very simple system, and at the end of the day, it's still good enough. Otherwise, you might say, no, actually, it's not good enough because I might need more complex systems every. I mean,
Yeah, but I guess that if you have those systems that are different, you can also use them for the simulation.
yeah, but suppose that you don't have them. And then you want to say,
Yeah.
even though I don't have them, still the simulation is good enough. That is the difference.
Well, I guess that you could like perform that experiment because nowadays we have those neural models. So I guess we can just build simulate the rooms with them and without them and compare the results. Yeah.
That would be my point.
Yeah, but I guess that would be a good point to explore.
I don't know if it's really useful, but just looking at your slides and wondering if you can play with that maybe as or
Yeah, I guess
estimation.
that would be a good idea.
Related perspective for the presentation. Can you go back when you show the result of the manual proliferation?
Yeah.
Because I missed this is related to this. So instead of models,
Okay.
do you find that manual
This table.
yes, title of manual period,
Yeah.
is it better than automatic review? The fact that you highlight them. So that the-
Well, the fact that I collected here is that because I was like talking about them, so it's actually to focus on this one. But yeah, we can see here that, for example, the correlations, the values from this row are higher than values from the row. So you get high correlations using the manual queries than what you get using the automatic ones.
Okay, so again, the correlation, so correlation between
The the ranking of the official systems. Yeah.
and look at better for your study to see a work correlation. So that, I mean, I don't know. But in the sense that you are actually getting more relevant topics and different stuff that some of the systems behave differently. So that, for example, I'll give you an example. I participated last year where one of the players was the event frog. And we did manual query variations.
Yeah.
And the overlap with manual query variations, but done by experts. With the pool was very, very, very low. In some points, it was surprising because the query was written in a much better way for a doctor rather than the efficient queries. So in that case, I would expect systems that behave differently, that use a different kind of query writing model to perform better when they have a wider set of relevant documents. So that's my point. Is it always better to have a good correlation with the official runs, or in this case, is it better to have a lower correlation because then you show that you include relevant information that was not record before.
Okay, if I got your point right, you are saying that maybe the manual queries are better than the official rankings, and so you want to difference from them, right? Well, that's a very curious point, but I mean, I don't know, to be honest.
After that, when you show that your model is more efficient in the sense that we then documents to achieve the same correlation with negative. So you have a way to get a more quickly, in a quicker way, relevant documents to that point. And again, in this case, I'm not sure if a perfect or not a perfect very good correlation with the efficient routes is a good thing since we are trying to give more relevant information for other systems that where bias is evaluated.
But I mean, the thing here is that all the I don't know how to explain, but all the relevant documents that the collection has are known, because you assume that those that were not in the pool are not relevant. So and apart from this, as far as I know, the collections are usually built using very different types of runs that usually include runs that were built with manual queries. So I'm not sure that
Probably your goal here is different from what, I mean, here you try to replicate in terms of or they give you systems are the same, but maybe you don't replicate it, you improve, but you can make the system right. And if you do that, then you take this idea and you put it together, you put our boundaries, so the other idea. And then you use both to generate, to get documents, to give documents to the assessors, then we might improve the whole process. Because say, we have that you have when you take a collection, half of the documents are improved with a network system, and the other half is something to right, something that will now. So you don't know which are the topics that are taken well or not, we need to propose solutions and then study with them. And so what you can, but here you compare because you are just pulling documents and you give them to the I'm just speaking of the assessors. But so say that you have different re-ranking systems. So you get your runs, you give one document that's relevant to the cell reference feedback, and then you use a network for the run, and then you get a relevant document. So you know that probably with an error model that topic is going to improve, so you keep using that. If it is not relevant for a number of times, you change the ranking model and you go to an extra one. And maybe it's improving because you have this problem that goes to the network, to the app, or vice versa, not always different. Often it happens. So if you mix these two ideas, you may have a further improvement. Just picking up.
Yeah, that could be a thing, but we only can evaluate that by paying the real assessors.
Oh yeah,
because maybe we are finding that would happen here. We are finding relevant documents. I mean, documents that are relevant but were not assessed originally. And so I guess that
there was one that it was bias, maybe your results higher, even if you agree or find something different. That was not good originally, so it's not relevant by definition at this point, and doesn't really change the rank of the original class. So you see an higher correlation. you were able to have the judgment not fully and including discovery documents, they were relevant and you were lower correlation with the so this may be a little bit overestimated.
Well, but I mean, I guess
I mean, here, yeah, actually making your own in the way.
yeah.
You are then taking the official answer, which did not participate in the pool because they took out all the scientific grant, and you see your correlation with the original track pool is good. But the synthetic pool is filtered by the documents charged in the original pool. So even if in the synthetic pool there were any document, that those documents in the synthetic pool would be not relevant by definition.
Yes.
So basically, you are just giving in the new pool, having a subset of the documents of the original pool. So
yeah,
this is possibly not changing the ranking of the original runs that much. And this may be why you see so good results. What you have to read is how fast you are in getting a subset big enough, which is the second part of this
yeah, I think before that could be a thing that we are discovering new documents that were not in the original pool, and maybe we had the resources to judgment this evaluation would be completely different, but you know, it could happen that maybe the correlations are even better or even worse because, as he said before, maybe if we have even better results than the original ones, we differ from them, but I guess that the only possible move here would be to pay the real assessors.
Yeah.
And but yes, my point here is that could be a thing.
Maybe I don't know if this would have, but recently they added judgments, right? Using never.
Yeah, there is a paper.
Not really strong in our users. The way this was started was a little bit interesting, but what we do not find because you already covered everything with the original floor because they are not pushing enough with them. So
Maybe if it was good, you can say, okay, I have this data and then see if I can fix. Simulate the whole process.
you can use the type of the draft where they give this collection indexes and they keep adding the documents, but they were also in topic, but they were also adding the judgments to the original set of topics. So there could be starting the text to simulate the condition more in a sense of
Yeah.
So that's good. And there was another one that they created, and then after a couple of years, they created a then they wanted to I remember the judge once, and after 2 years, the judge was another sort of the last only they assessed some of the possibly people are about to leave people one thing or something like that. So, yeah, anyway.
Okay. Do you have any questions, guys? And I don't know if you will be interested some people about it. You think that we can start?
So I was wondering when they got the city also looking to the number of significant differences found by more. I mean, even though we're using the best judgements and we are finding this in our random. Important thing is probably to find significant differences between systems, so should there be a lot that aspect of that level, we're able to find the same number of significant differences or at least same possibility different that
Yeah, that would be a good point to explore, but I believe that, well, for example, if you take this road and you have 0.94 correlation, that means that your rankings of systems are really similar. So maybe I mean, if the ranking is mostly the same, I guess it would be very unlikely to find differences, different statistically differences with respect to the original pool. But anyway, yeah, that could be.
I think that only the design same. My point is maybe the left is less output and less able to very one when systems are statistically different, and then that would be a problem even though the environment is exactly the same. Still, you are not able to access differences between the systems. Then, yeah, that's good sort of thing. I mean,
Yeah, I agree with you. It could be a good experiment to perform because it is something that we have not done yet.
yeah, and also on the other side, finding the very different, right? Sort of very different, but how each only non-significant different systems that we fixed. I don't think it is a problem. Definition, they are not statistically the same, and I mean, if they are statistically the same, then one are above the other just terms. So we consider removing comparisons.
Yeah.
Okay, any other questions? So, thank you.
Grazie.
We are done.